Fleas are small, wingless insects that belong to the order Siphonaptera, and they are most commonly known for their parasitic relationship with mammals and birds. These insects are highly specialized for a parasitic lifestyle, feeding on the blood of their hosts to survive. Despite their tiny size, fleas are among the most resilient and adaptable of pests, capable of thriving in a wide variety of environments, and they have been responsible for the transmission of numerous diseases throughout history, most notably the bubonic plague. The life cycle, behavior, and impact of fleas on both humans and animals have made them an enduring subject of study, with their persistence and adaptability serving as a testament to their evolutionary success. Fleas are typically about 1.5 to 3.3 millimeters in length, with a laterally flattened body that allows them to easily navigate through the fur, feathers, or skin of their hosts. Their bodies are covered with stiff, backward-facing spines that help them move through the dense hair or feathers of their host animals. Fleas are most often found on mammals, such as dogs, cats, and rodents, but they are also commonly associated with birds. These insects are external parasites, meaning they live on the surface of their host rather than inside the host's body. Their main goal is to feed on the blood of their host, using specialized mouthparts that are adapted for piercing the skin and sucking blood. This feeding behavior is essential to their survival, as they require the nutrients found in blood to reproduce and sustain their life cycle. The feeding process of fleas is highly efficient. They use their specialized mouthparts, known as a proboscis, to pierce the skin of their host and access blood vessels. As they feed, fleas secrete saliva that contains anticoagulants, which prevent the blood from clotting and allow them to feed more effectively. This saliva can also cause an allergic reaction in some hosts, leading to itching, irritation, and discomfort. In some cases, fleas can transmit diseases to their hosts through their saliva, which can include bacterial infections such as Yersinia pestis, the causative agent of the bubonic plague. Although fleas are most commonly associated with pets and livestock, they are capable of infesting wild animals, including rodents, rabbits, and even wild birds. Fleas are exceptional jumpers, capable of leaping up to 200 times their own body length. This impressive ability is made possible by their specialized legs, which are extremely powerful relative to their size. The hind legs of fleas are especially long and muscular, allowing them to leap great distances in a single bound. This jumping ability is crucial for fleas, as it allows them to move from one host to another and to escape potential threats. It also helps them to disperse to new areas in search of food and shelter. The ability to jump also contributes to their success as parasites, as it enables them to easily move between animals and to find new hosts when necessary. The life cycle of a flea is composed of 4 stages: egg, larva, pupa, and adult. Flea eggs are laid on the host animal, but they do not remain attached to the host. Instead, they fall off the animal and land in the environment, such as in bedding, carpets, or outdoor areas where the host spends time. Flea eggs are oval, smooth, and white, and they hatch into larvae in a few days to a week, depending on environmental conditions such as temperature and humidity. Flea larvae are small, worm-like creatures that are blind and rely on their sense of touch to navigate their environment. They feed on organic matter, including flea feces, which is composed of partially digested blood from the host. The larvae are also sensitive to light and tend to seek out dark, hidden areas where they can continue to grow and develop. As the larvae mature, they enter the next stage of their life cycle, the pupal stage. During this stage, the flea larvae spin a cocoon around themselves and enter a dormant phase known as pupation. Flea pupae are highly resilient and can survive for long periods of time in a dormant state, waiting for favorable conditions to emerge. This ability to remain dormant is a key factor in the flea's survival, as it allows the flea to wait for a host to come nearby. Flea pupae are also highly resistant to environmental stresses such as dehydration, temperature extremes, and even insecticides. This makes controlling flea populations challenging, as the pupal stage can persist for weeks to months before the adult flea emerges. When a flea pupa senses a potential host nearby, typically through vibrations or heat, it emerges from its cocoon and becomes an adult. The newly emerged adult flea is fully capable of jumping and seeking out a host to feed on. Once a host is located, the adult flea begins the feeding process, and the cycle starts again. Adult fleas are small, dark-colored insects with a hard, smooth exoskeleton that is designed to withstand the pressures of their parasitic lifestyle. They possess specialized mouthparts for piercing the skin of their host and sucking blood, and they are highly adapted for living on the surface of their host's body. Once they find a host, adult fleas can begin feeding within minutes, and they typically feed several times a day. A single flea can consume several times its own body weight in blood each day, and they can survive for weeks to months on a host, depending on the availability of blood. The reproductive capacity of fleas is another reason for their success as parasites. A female flea can lay hundreds of eggs during her lifetime, with some species laying up to 50 eggs per day. These eggs are laid directly on the host, but as mentioned earlier, they eventually fall off the animal and land in the surrounding environment. Fleas can reproduce rapidly, and the high reproductive rate contributes to their ability to infest both domestic and wild animals. Given the short lifespan of adult fleas, which ranges from 2 weeks to several months, their ability to produce a large number of offspring ensures that their populations can grow quickly. Fleas can be a major source of discomfort and health problems for both humans and animals. The bites of fleas cause itching, irritation, and allergic reactions in many hosts, and in some cases, they can lead to more serious health issues. Fleas are known to transmit a number of diseases, including Yersinia pestis, which caused the infamous bubonic plague outbreaks in Europe during the Middle Ages. Fleas are also vectors for other bacterial infections, such as Rickettsia species, which cause diseases like murine typhus. In addition to bacterial infections, fleas can also transmit parasitic worms, such as tapeworms, to their hosts. These diseases and the discomfort caused by flea bites make them a significant health concern, particularly for pets and livestock. The impact of fleas on human health has been particularly notable throughout history. During the Black Death, which occurred in the 14th century, fleas played a crucial role in spreading the plague. Fleas that infested rats carried the bacteria Yersinia pestis, and as the fleas fed on the rats, they became infected with the bacteria. When the fleas bit humans, they transmitted the bacteria, causing widespread illness and death. It is estimated that the Black Death killed millions of people in Europe, making it one of the deadliest pandemics in history. Today, the risk of plague transmission through fleas is much lower, but fleas still pose a threat to public health, particularly in areas where they are prevalent. The challenge of controlling fleas has led to the development of a variety of pest control methods. Traditional methods of flea control include the use of insecticides, which are designed to kill fleas in various stages of their life cycle. These insecticides are available in many forms, including sprays, powders, and topical treatments for pets. However, the use of chemical insecticides has raised concerns about the development of resistance in flea populations, as well as the potential for harm to non-target species, including humans, pets, and wildlife. As a result, alternative methods of flea control, such as natural remedies and biological control, are also being explored. One approach to flea control is the use of natural predators, such as certain species of parasitic wasps or nematodes, which can help reduce flea populations in the environment. These natural enemies target flea larvae and pupae, disrupting the flea life cycle and reducing the number of fleas that emerge as adults. Additionally, maintaining good hygiene practices, such as regularly cleaning and vacuuming areas where fleas are likely to live, can help to control flea infestations. Pets should be treated with flea control products to prevent them from becoming infested, and outdoor areas where pets frequent should be kept clean and free of flea larvae. Fleas are incredibly resilient insects, and their ability to adapt to a wide range of environments and hosts has ensured their persistence over time. Their small size, rapid reproduction rate, and efficient blood-feeding behavior make them highly effective parasites, and they have caused significant health problems for both animals and humans throughout history. While fleas are often associated with discomfort and disease, they also play an important role in ecosystems, serving as a food source for a variety of animals, including birds, amphibians, and other insects. The challenge of managing fleas continues to be a topic of research, as scientists work to develop more effective and sustainable control methods.